Hi, I am conducting a series of experiments. I want to use the characteristics of sound wave reflection to find potential items underground. We all know that sound propagates at different speeds in different mediums, from fast to slow or solid, liquid, and gas. My goal is to get a lot of data on the speed of sound in various specific mediums. In the future, this could help us quickly find water sources underground and more quickly understand the conditions beneath undeveloped land. For the experiment, I set up 2 amplifiers connected to 2 microphones. Then I'll generate sounds at different frequencies to test and find the hertz range that works best for this experiment. This is a schematic video that shows how this experiment works. By using an application on MATLAB called Analog Input Recorder, I can record the data for sound waves easily. I can also set the scan rates and duration with this app. Additionally, this is the code I use for saving all the data. For the first experiment, I inserted 2 microphones and buried a speaker in the sand. The 2 microphones are 30 centimeters apart, and the speaker is 10 centimeters away from the first microphone. This is the result, and I found some problems. First, the sound waves were too dense and difficult to read and analyze, so I changed the continuous sounds into intermittent ones. Second, I found that the data generated by sounds with too high frequency are difficult to analyze. Future experiments will only use 5 sets of data of 100, 150, 200, 250, and 300 for testing. Finally, in order to record the data more accurately, I will first do an experiment with the speed in the air. This is my second experiment. Except taking the microphone out of the sand, the rest of the conditions remain the same. This is the data obtained from the second experiment. Magenta represents the first microphone and blue represents the second microphone. This let me know the time of flight, then use distance divided by time to get the speed of sound. After calculation, the experimental results are very unsatisfactory. The speed of sound should not change with different frequencies. So I adjusted the scan rate to the maximum value, but the data I got was still wrong. The speed of sound still varied with frequency. However, the data obtained by the maximum scan rate is relatively stable, and the speed at each frequency remains consistent. Because the data obtained from previous experiments were not ideal, I decided to take the microphone out of the container to test it. But the data obtained under such circumstances is still difficult to analyze. I decided to extend the distance between the microphone and the speakers. The various data obtained are still not getting better, which is frustrating. Finally, I found that there was a logo on the microphone. I put both the logo side facing the speaker, and put it back into the container and tested again. Unexpectedly, reasonable data were obtained. The sound speed at all frequencies is within a similar numerical range. However, 200 Hz was not recorded due to unknown technical issues. This is my current progress, and this is a brand new project and will continue. Although I am still in the early stages, I will continue to overcome difficulties and find the results I want. Thank you.